So 7.3 is problem solving using maps. We're kind of going into what we've been doing the last couple days with maps and scales and things like that. But now basically you're getting story problems associated with the maps, some of which are going to give you a couple steps to do. And here's some equations that will really come in handy. So distance equals speed. Oh, I told her the date a little while ago. Speed times time. So one equation is distance equals speed times time, or normal people just do lowercase d equals s times t, all lowercase letters. Distance equals speed times time. My s is a little bit messed up there. But the other one that often comes in handy is going to be a time. A lot of time the questions are going to be, how long is it going to take to do this thing here? So if we were to take this original equation, we want to get speed out of there if we're trying to solve that for time, and I wouldn't mess this up. But do you agree if I divide by speed, so I wouldn't write this blue stuff, but if I divide by speed, do you agree that would give me time by itself? So I wouldn't change your red one, but essentially though what we're finding is time then is going to be distance divided by speed. Or if you actually just write the letters, so we have d equals s times t, or t equals d divided by s. So I'd have those written somewhere. You could add them to like a bookmark that I've given you with equations on them if you wanted to, but those are going to come in handy as we go and try to do some story problems in the next little bit. One comment about our book refers to the speed as the rate. And they're probably just trying to tie it into our last chapter on like ratios and rates and proportions. But speed is a rate. It'll be like miles per hour, feet per second, something like that. But you're going to get some story problems kind of along the lines of this. So we'll say example 1. And I'm going to, because instead of trying to draw the whole picture, I'm probably just going to kind of include that a little bit in my thing. But I'm going to say library to home. I probably wouldn't bother drawing it, but I'm going to say library to home is 3 centimeters on the map. And then the question is going to be how long to get home. So we're not asking for the distance, we're saying how much time to get home. If the scale is 1 centimeter, colon 2 kilometers, so 1 cm, colon 2 km, and you bike 20 kilometers an hour. So we really have kind of 2 questions in here. First thing you need to do is you need to figure out, well, how far is it? And then you have to figure out how long is it going to take you at that speed to go that far. So Abby's saying 6. Do people agree? And if you're not seeing that, the way to set it up is to start out with, okay, I have this 1 centimeter and 2 kilometers. So you could say 1 centimeter over 2 kilometers. You're going to make a proportion. And you don't have to write all this out if you don't want to. But if you get one that you can't easily do in your head, this is how you come up with it. Well, we now know that it's 3 centimeters on the map from home, that spot there, to the library. So we put our 3 centimeters in the numerator. That's what we were doing yesterday. And we're looking for what's that distance in kilometers. So then we say 1x, when we cross multiply that way, equals 2 times 3. So we get x equals 6. Now the best way to do it would be to actually be putting my units in this step here where I cross multiplied and then I divide by 1 centimeter and so on. But what you could do if you wanted to is, well, we just found x, which is right there. It'll have the same units as right there. So it's 6 kilometers. Fair enough? So it'll have the same units as the other denominator was. So now we're looking for how much time. So we could jump back to our last, I should say, any questions up to there? Didn't think so, because that's like the review part. But now we're looking for time, so we could go with this equation right there. So t equals d divided by s. So if we say time equals distance divided by speed, or distance divided by rate if you're reading the book. So my distance is 6 kilometers. and my speed is 20 kilometers per hour. So we could plug in 6 divided by 20 gives me 0.3. And what's the units going to be if my time is 0.3? Go back here. What's the only time unit in there? Hours. So it's going to end up being 0.3 hours. Which then, if you wanted to figure out the number of minutes, you could say 0.3 hours times 60 minutes per hour. And then that would give you, so you'd end up with that it's 18 minutes if you wanted to. So you could leave it as the 0.3 hours in this case, or if you wanted to, you could say 18 minutes. But I'm okay with the 0.3 hours unless it says how many minutes is it going to take you to ride home. How are we doing on that example? Does that one seem good? Make sense? Cool. I have another example going to add just like one more step to it. I'm going to say for that, so example 2, and I kind of jumped the gun a little bit with my example 1, but I'm going to say if the biker leaves at 6:05, when will they get home? When, or maybe just say when home, question mark. Bad English, but shorter. So if the biker leaves at 6:05, when home? And the reason I kind of jumped the gun is initially my plan was that we would just have like the 0.3 hours. So you'd be at 6:05 plus 0.3 hours. That doesn't really work, right? At least in my head, I don't know what to do. But we saw how to change that 0.3 hours to 18 minutes. Oops. So if I take that and say, all right, we know it's 18 minutes is the 0.3 hours. So if they leave at 6:05, it's another 18 minutes. They're going to get home at 6:23. Yep. So it's kind of like we have like, maybe put my 6 over here, so it's like 6:05. You add it on 18 minutes, so you get 6:23. That'd be a little bit rougher if you were like going over into like 7 o'clock. Maybe I should do that here. Let's say that you have, okay, is that okay for everybody, 6:23?
6:49.
Okay, yep, so if we say instead it's 6:49, so if it had been 6:49 instead, and you add 18 minutes to that, what time does it end up becoming? I guess I'm not sure how to explain this. I didn't really plan on this, but 6:49. Do you agree that give you 6:67? Yes? Like if I just were to do the, yep, because that's 49 plus 18 is a 67, right? But once you hit 60, you're over to your new hour. So Abby's right on. That it would end up being 7. And that 7 takes away my 60 from right there. So just 7:07. Does that work for people?
Yes.
So this last example explains maybe my Sunday mornings a little bit. You're running late for church. You're trying to find the fastest way to church. So what's fastest? Actually, I probably should have used you're late for swimming lessons Saturday mornings. We're often running late for that too, and then I could take the highway. But say you have two options. Let's say you have an 8-mile route on highway. So that's supposed to be an 8 mi highway. The average speed, I'm just going to do AVG for average. Can I get away with that? Average S equals 55 mi over h. Because I'm doing some highway at 70 or 77 or something. And some city streets, so I'm figuring my average is going to be about 55. So that's one route. My second route is shorter. I could take the straighter way there, and it's only 5 miles. And so this is like normal roads or surface roads. So surface streets, non-highway. But now my average speed is just going to be 30 miles an hour. So now the question is, which way is going to be the fastest? Which way do I go if I'm running late? What equation should I use? We're looking for time, so it'll be time equals... Nice. Thank you, Marielle. D divided by S. So In this first one I have 8 miles divided by 55 miles per hour. And if I punch that in, I get 0.145 with the 45 repeating. So 0.14545454545. I could multiply that by 60 if I wanted to, and we get a certain number of minutes. My second time, I could even write T2 if I wanted to. We'll skip the T2, but T or T2 equals distance divided by speed. Now I do 5 miles divided by 30 miles per hour. And if we punch that into our calculator, we get 0.16. 6 is repeating, right? And for that, we could look back at our original equation there too, our fraction, and say, okay, the only time unit there is hours. So that's 0.16666 hours. This is 0.145454545 hours. So the fastest one would be to take the highway. And you could, if you wanted to, like I said, multiply both of those by 60, and you get that this here would be 8.7 minutes, and the other one would be at 10 minutes. 10 minutes. Both boys do.
Where?
The YMCA. So, we okay on those? One thing, just so I feel like a slacker. The notes are done, really. But I want to show you one thing. When we have this miles divided by miles per hour, this is something that a lot of my high school kids couldn't do. But you guys are like way better at doing fractions than them because you've had to do them without a calculator. But do you agree if I took that, that's going to be the exact same as miles over 1 divided by miles per hour? I can convince you that that's true. And when you're dividing fractions, that's the same as taking the numerator. I could change it to multiplication if I do what to my denominator? Do the reciprocal, right? So if I flip it, now I have hours over miles. And when we're multiplying fractions, you can cancel out something in the numerator or something in the denominator. So when you do that, you're just left with hours over 1. So that's why if you have a problem like this, the miles drop out, and you're just left with an H in hours per units.